Hello guys, so today we're going to look at transformations of cubic and cube root functions. So the word comes from, if you imagine you had a cube, and let's say my cube is 2 feet by 2 feet by 2 feet, let's say. To find the volume of that, you would take 2 times 2 times 2, which is 2 to the third power, which we call 2 cubed. So we call the third power cubed because when you take a cube that is this size on each edge, then you are taking it to the third power to get the volume. So cubic. And then cube root is just the inverse of that. So if I start with, and by the way, that's 8. If I start with 8 and I want to know the cube root, we write cube root by writing the radical symbol, so the same symbol as with the square root. We put a little 3 right here. That is not multiplication. Not multiplication. So it's not 3 times the square root of 8. It's the cube root of 8. So kind of put a little bitty 3 sitting on that shelf. And this means what times itself 3 times will give you 8. And of course, as we saw before, 2 times 2 times 2 is 8. So the cube root of 8 is 2. You can also write it with a 1/3, so 8 to the 1/3 power is the same as writing cube root of 8. So that would also be 2, because that means 2 times 2 times 2 is 8. So just kind of remember that this is not division that we're talking about. We're not talking about 8 divided by 3. This is really not something you can do in your head unless you know your times tables really, really, really well, especially once the numbers get bigger. So we're going to start out by graphing the function, both parent functions, and I'm going to color code them. So I'm going to make the cubic one orange. And I've got this nifty orange erasable pen. Look. Oh, it's a pen and it erases. Oh my goodness. So I just want to show you this awesome pen that I have. It erases. Okay, so I've got, if x is -2, and then I need x to the third. So I'm going to take -2 times -2 times -2, which is -8. So I'm going to graph the point -2, -8. 2, 3, 4, 5, 6, 7, 8. And then I have -1, so -1 times -1 times -1 is -1. So oops, right there. I can erase my mistakes even though it's in pen. Check that out. And 0 times 0 times 0, of course, is still 0. So I'm just going to go ahead and fill these in for you. And those two won't fit, so we're just not going to graph those. So this has kind of a little bit of a curve to it, like that. And it's not quite straight, but it is really steep. So it can be kind of, oops, that's actually really bad. It can be kind of tricky to draw neatly, this one. Silly cubics. Okay, so there's my cubic function. So f of x equals x cubed. All right, now the cube root, you can grab your calculator, and actually I'm going to grab it and show you. So I want the cube root of -8. So what I want to do is type control and then use the exponent key right here, because it's got that nth root is what it's called. There. So put a 3 for the root and put a -8. Now, if your calculator is still in complex number mode, from earlier in the year, it's going to give you an imaginary part there. We don't want that. We just want real numbers now. We're back to just real numbers. So if this happens to you, you're going to have to go to menu. Wrong. Don't go to menu. Go to doc. Settings and status. Document settings. And change real or complex back to real. And then go ahead and make it the default again. Yeah. Okay, and then do it again. And then you get -2, which is what you want to get. Which is what you're supposed to get. And you could also type it with a 1/3 exponent. So parentheses, -8, parentheses, exponent key, 1/3. And it's the same thing, so you do get the same answer of -2. So cube root of -8 is -2. Oh my gosh, you guys, I didn't switch colors. What the heck? So let me erase the orange one because that is wrong and do it in purple. Okay, so now notice what happened here. Notice that -2, that used to be an X, now is in the Y column. And the -8 that used to be in the Y column is now in the X column. What? That means these are inverses, because the X and Y have swapped places. So just keep that in mind as we go. So now my former Y value of -1 is now an X value. So that means my former X value will now be my new Y value, -1. 0 is still 0, 0. So 1, 1, 1. 8, 8. So my old X value of 2 is now my new Y value of 2. Or you could type these in your calculator, but hey, why not do it this way? It's quicker. So the cube root of 27 is 3, because 3 times 3 times 3 is 27. And the cube root of 64 is 4, because 4 times 4 times 4 is 64. So I'm going to go ahead and graph those now. So there is my, I'm going to go ahead and call it f inverse, because this is the inverse of the function, like that. So remember that little -1 means inverse, equals the cube root of x. And put your little 3 there, and again, that's not times 3, the cube root. So if you need to pause that to copy it, then go ahead and pause it. So we've got our transformations of cubic functions, which follow the same rules as all our other transformations that we've done all year. So your a value that is multiplied in front of the parentheses still represents your vertical reflection, vertical stretch, and vertical compression. So flips upside down, stretches taller, and gets squished shorter. B, which we still don't use that often in this class, is your horizontal reflection, horizontal stretch, and horizontal compression. This one, H, is still your left and right. So left and right. And K is still your up and down. So none of that has changed. It is still exactly the same thing as all the other functions. Now you guys are getting pretty good at these, so hopefully you should find it pretty easy. Okay, so let's just try a few. So on the first one, I have my cubic function. So this little 3 exponent is not a transformation. That's just the type of function it is. It's cubic. The 3 in front. So that's going to be one of these, or possibly more than one of these. So times 3. I think if I make things 3 times bigger, it's going to get taller. So you know what? I'm going to go ahead and draw my parent function in here. Parent function. So this is going to be 3 times taller than this one. So this is a vertical stretch. This moves 1 to the right. So remember, your left, right are kind of the opposite sign you think they're going to be, because there's already a negative sign in here. So minus a positive number versus here that would be minus a negative. And up 2. So I'm just going to sketch this on here for you. I'm going to take it right 1, up 2. Heck yeah. There's my orange one. So basically the same idea. Let's just talk about one more together, and I'm going to put some of the other three into a question for you in just a minute. So I've got a negative sign. Remember that flips it upside down, so that's a vertical reflection. I've got a vertical compression. So it's compression because if it's between 0 and 1, so between 0 and 1, think about this is going to be half as tall, so that's a compression. It's getting shorter. And I'll draw it in just a second. And this is left 2. So let me grab my pink. It's going to be pink. And so I'm going to start here. I'm going to go left 2, 1, 2. So there's my starting point. And it's going to be upside down, so it's going to not go up this way, but instead kind of go down that way. It's half as tall. There. Right there. There. And zoop. And zoop. Like that. And so there's my left 2 vertical compression. Can you see it's a little bit flatter, kind of along the middle? It's probably the easiest place to see how it's flatter than the other one. So that's your compression. And your vertical reflection because it's been upside down. That way instead of that way. So, okie dokie. So let's now try the cube root. So same rules as before. Same one you've always done. Vertical reflection, vertical compression, vertical stretch, and so on. You know what? I'm going to let you fill that in because it's the same ones you're used to. And we want to graph the following functions using transformation. So let's graph our parent function first. Isn't beautiful? So let's now try number 6. So number 6 only has one transformation. So please remember that this is not a transformation. This just means cube root. But this is a transformation. So x minus 5, that's our h value. And since it's x minus 5, that means it went right 5 because, again, the sign is the opposite of what you would expect it to be. So let's go ahead and graph this in there. So it's going to look exactly like my parent function, just 5 to the right. 1, 2, 3, 4, 5. So there's that 0, 0 moved over 5. This one also moved over 5. This point also moved over 5. And this point, 1, 2, 3, 4, 5, moved over 5. And then I just have to sketch it in. Probably made that one a little bit too steep, actually. But I'm not going for perfection here. Try not to make it too... You know what? I'm going to fix that. That bothers me. See, and it erases both colors, which is a little annoying. So I have to draw my parent function back in there. Okay, so here's number 6. Beauteous. And let's try one more. Let's do 8. You know what? We don't see a lot of horizontal reflections or anything. So let's do that one. So this has a horizontal reflection. So that's your B value. Horizontal stretch, compression, or reflection. And this is a reflection because it's negative. And then this is an up 1 because it's outside the cube root. So I'm going to take my center point, 0, 0, and it's going to go up 1. And the horizontal reflection you're not going to see on that center point, but you will on the others. So this one goes up 1. So this point right here goes up 1, and it flips horizontally, so it's going to be over here. Let me erase that little mark. Whoops, there. And this point also moves up 1, and then gets reflected horizontally, so that way, right there. So I am going to ask you about some of these others here in just 1 second.